Let's recap what we did last time. We were still working on enable VR multiplayer presence. We have created a camera at a fixed location based on a spawn point. So if the user has no location, use a spawn point, and okay, so we did this. Create an entity, call the spawn point, which you can specify in a space, and if there isn't one, then we just use the origin, I believe. Let's see what happens. Is that what happens? Let's see. Or I believe that is what happens. Yeah, we have this method called find my position, and we look for session storage. Otherwise, we try to find the spawn point. And let's look at what this does. Okay, so in here, if you can't find an entity with a spawn point, you'll just return this thing, position 000. Otherwise, you'll return position X, Y, and Z located in the spawn point. And so either way, you'll have a spawn point, and then you'll set that into the session and return the spawn point. Otherwise, you'll return the previous spawn point. So we created the entity, we passed the spawn point to the channel. And this isn't really necessary anymore. Why do we pass this in? Was because we can, okay, set the initial location in the ETS table, but we're also going to set the ETS table whenever we move. Okay, but if there's no movement, this is important for setting the initial position. Yes. Okay, so we'll keep that. That's there. We created a owning process for the ETS table, which is the server, space server, and that has a space supervisor and a registry. We created an ETS table to store position so far. We need to add rotation. And then we added, we do store the, yes, we store the user's location in the ETS table when we register, when we join the channel. And this was about race conditions, which we've avoided for now. And we've addressed storing this in local storage. So on to the new stuff. Here we update the camera anytime we move our cursor keys. So we want to be able to hook into that and then send a message to our channel server, which will store position rotation updates in the ETS table and broadcast message to all connected users, and then in the users we'll receive all messages in the client using a pattern matching library, which there is a good one called match toy. Okay, so on camera move, we want to find out the camera position and rotation. So where is that? Well, in Orchestrator, this is the front end. We are creating the camera where? Let's look for camera. Create a free camera. Here's the camera business here. So we can maybe extract this stuff out into a create camera method. And we'll just take these guys, including this experience, and pop it in here. So because we have an await, let's make this async. And remove this comment. Let's just say create camera, this create camera. Okay. So in this create camera, we created it at the find my position location. And then let's add a hook so that camera on view matrix changed observable, and what do we do? We give it this, or is it add? And add a new callback. So anytime we, and I think this is the camera. So let's just console log this out. Cam position. Let's say it's the cam.position. Just on stringify. And console log cam rotation. Well, let's start with one thing at a time. We have this ix-x Phoenix server. So now, if we open up a browser and go to, let's say this space here, go to the bottom, and if we move it, yes, we get a huge number of points. And we can see from this that when I release the button, I'm still moving just a little bit. So many data points, and they're quite there's quite a bit of significant digits here. Okay, and when we rotate, the position isn't changing, but we're generating a lot of messages here as well. Okay, so this is good. We want to send this along. So in order to be able to throttle it, there's this library I liked called rxjs. So we can send them along to that, and then it gives us the ability to subscribe to this and throttle it. So we need to bring in the rxjs library. So rxjs cdn, maybe not the rxjs cdn, maybe we could just bring in rxjs with just the functions that we need. I think it will probably use tree shaking. So let's do that. So let's add that to our package. So where are we? So we'll go to assets and we'll do npm install rxjs. Is that how you do? I think so. Let's do this. And we have updated the dependencies. Now has rxjs. And I'm not sure if I need the types, but we can bring in the library that we need. So import here and import something from rxjs. What do we want to import? We want to import subject. I think it's called a subject. And what a subject can do is public signal we need a place to send these kind of messages, right? So I'm kind of treating them as signals, and maybe we can just call it signal bus, or it's a type of signal, but there are different kinds of types that it could be, right? Subject. It's a type of subject, and I think this needs to be something, like it needs a type. So it could be string, it could be any. So maybe what if we have a event, signal event. It's a type with the event is a string. What else? And it has a payload of any, which kind of matches the payloads that we're giving to Phoenix channels. Because if you look over here, are we sending anything? Let's see, receive OK, on message, on component. We need to see a push. Do we have any push? Look for the word push here. No, we don't have push. Okay. But in any of these messages, we're getting an event and a payload. Here's the event name and then a payload. So let's say that the signal event is just event and a payload. So that this thing can be a subject of type signal event. So this is the bare minimum of what needs to go into this thing. Then in our constructor, we can create a new one of this. So signals is new subject, and it's just waiting there for events. And then in our create camera, we can put a message into this signal. We can say next, and then we can construct a signal that matches that. So we can say event is camera moved, and the payload is, let's say, the position, which is cam position, which in our output here was okay, you get X, Y, and Z. It's a thing over here. So camera position as array, maybe. So if we start our server, it should, let's see, npm, /x, let's see, server. See what happens. Oof. Get ets ref, no process alive. Where's this call from? Gen server space channel. Oh, huh? No. Oh, maybe race condition. You're calling this where, yeah, this doesn't exist. Oh, because I think this page is already there and this thing's trying to connect, but the server was down. And so if we just refresh like this, we will be fine. Okay. All right, so when we move the camera now, we're still getting this output because of this. But I want to demonstrate that we can get the signal from someplace away from this code now. So we're sending events through this thing, and out in the constructor, we can actually subscribe to it and just listen for events coming down here. So we could say, so do we have a start thing happening? Let's go to the very bottom. We say orchestrator start. So it's initialized, and then what happens in start? Yes, we set up the canvas, the engine, then we create the scene. Run the render loop. Yeah, I guess I could put it here somewhere. So once the scene is created, we could say that this signal, we could subscribe, and we're subscribing to some message. Right? So we have some message. We're going to do something about it. So we can just console log this message. Console log, what is this message? Okay, so we're getting camera moved. Okay, so we have event and payload. Camera mode is correct, but payload seems to be missing some data in here. Why is this? Let's see how we handle the camera part again. You might have screwed something up. Create the camera. Payload. Okay. Okay, let's give something back simpler. Let's just say position, and it's like 1, 2, 3. So if that were the case, okay, that works. And what is the position? So if we console log camera position as array. Okay, it needs to be a function. So if we have this, okay, now we have numbers. And I kind of feel like this array is too, what do I say? Let's map over it, giving each value truncation. So can we remove some of the digits? By taking the value, there's so many significant digits on it, I kind of want to just round. But if you round now, what will happen is you'll get just this part here. So we want to maybe multiply it by 5 digits, round, and then divide by 5 spaces. So value multiplied by 5 spaces, and then you will do math round. And then take this value divided by 5 spaces. it should truncate the let position array equal this, and then we console log position array. Okay, I think this achieves what we want. Is just a smaller amount of precision. We can go one digit more, I think. Let's go to spaces. And then we'll stick that as position array. There's a lot of inertia on that. Can we turn that off? Camera, babylonjs, camera inertia. Camera inertia equals 0. Yes. What is the camera inertia? Console.log camera inertia. What is the value on that? Camera inertia 0.9. Okay. Let's just turn that way down. Camera inertia equals 0.01 maybe. Okay. Close this. Okay, it's totally off. How's this? Feels like it's off as well. Might as well be totally off as well. It feels like it has none. This, to me, whoops, feels like it might as well be 0. I mean, if there is anything, it's so imperceptible. That actually feels pretty good. Okay. So we have this camera moved put in, and we could also send the rotation so let's get this to the back end first. So we have this in the signals, and what we need now is to send them with a push. So where we're subscribing them with a signal, and here we're reading them, we want to now push them into the channel. So we could say this dot channel space channel dot push, and we want to make sure that this is connected, which in fact the message we only want to push on a certain type of message, so it has to match something. We only have one, so this will work. And space channel, you might get an error if you start moving it before you make sure that space channel is joined and socket has to be joined, which there's no guarantee of that because this is just happening here. So in orchestrator start, it should maybe have an async here, and then we can do await. See which of these is a promise that you can await on. The channel gets a channel join, returns a push. These don't return promises, even though, well, actually, connect and join don't return promises. So I have nothing I can await on. Okay, maybe it takes care of it. So, okay, in my start, I'll just say space channel push, and I'll say message event and message payload. Okay, so we're sending that through. So when we send it through, we should get a crash over here that there's no handler for this. So if I do this, yep, we get a crash over here because we have a handle in, camera moved, this business, and it crashed and restarted it. So we need to implement that. So we'll go to space controller, space what? Channel, and we'll create a handle in. We'll redo this one. It will be camera moved. And then we have a payload. And we can broadcast. We can broadcast here. We can broadcast the position to everyone. Broadcast from. And we can say member moved, and then our payload can be the member ID, which is socket assigns member ID, and position will be payload position, or let's say position, which we know we're going to have one from position being position. And that's the only thing we care about right now. Alright, so move this over to the side so I can see the terminal output here. What is going on? Camera moved. Oh, wait. Phoenix message. No function clause matching in. Handle in. Camera moved. Position. This. Oh, you got more than that. We got position, Phoenix socket. Oh, no, that's right. We got position. Let me just restart this. Okay. I move this. Handle camera move. Yes. And I back it up. Yes, we get all kinds of nice data here. Very good. And we should be getting some. Oh, look at this. We get event channel reply. So we're getting some other data that's coming through here. So if we have another person attached, let's say on Firefox, so we're getting this event member moved, and if we were to expose this, he's at 13 here, and then here he's at a slightly different location. Yes, these numbers are different. Oops. Yeah. Okay, so we're sending it across. That's working. And we can close this. Close this. So what's interesting here is in the channel part, we have these different handlers for on messages. Actually, this is a catch-all. So this handles everything, including some of these messages that we're not doing anything with. So I was thinking we could use the pattern matching part instead of having to create one of these things, this is similar to pattern matching as well, but then we have to dig into this. And so I think using the pattern matching could be powerful for destructuring this thing. Although you kind of get the same benefit if you just destructure here directly, right? We can just say when you get someone moved or camera moved and you do something. Yeah, maybe we don't need the pattern matching yet. We just say when we get one of these messages, do something. But we are also sending this message very, very frequently right now, which is another thing. Okay, so let's not worry about that. We need something for this space on member moved params. And can we do some destructuring like this? So we can say member ID and position. And console.log getting member moved. And here we do JSON or just member ID and position. Perhaps not as powerful, but let's see. All right, so let's open up our experience again. We won't get our own messages, so we'll also need to open up Firefox. Okay, cool. I'm getting plenty of messages this way. All right, so we have that part. We need to add some throttling, which we could do in the channel push part. So this is a signal that has camera movement on it, and we could do a pipe here. So when we pipe, we can filter, we can do other things on it. So we could say send camera movement, and we need to do a pipe. Hold on. Inside pipe, we need to have some operators. But one of them is filter, which we have to import as import filter from RxJS operators. This filter, oops. This filter takes the message and returns true if this is a message that you can handle. So if we say message event equal to camera moved, this will be true and the message will go through. And in fact, we could say that the message type here is signal event. Which I think it knows this already. It might know this already. When we do this, yeah, it knows. Okay. So this signals pipe filter only on these kind of messages, and then we can do something like throttle with the frequency. How about 250 milliseconds, which we need to import throttle. Emits a value from the source observable, then ignores subsequent source values for a duration determined by another observable, then repeats this process. It's like throttle time, but the silencing duration is determined by a second observable. Now we want throttle time. Throttle by time emits where its internal timer is disabled, ignore source value. Example, throttle with an interval. see throttle time. Maybe what we want is throttle time. Emits a value from an exorbiter for duration milliseconds. It repeats this process. So pipe throttle time, that limits to once per second, and we want once every tenth of a second, maybe. Throttle time. Then, when we subscribe, we'll get way fewer messages. We could start off with something slower, 250. Okay, so now if we go back to give me a browser, localhost, spaces, and give me Firefox. Host A. Okay, we get a very slow, kind of steady stream. It's a little too slow. We go maybe a bit faster than that. 100, 10 times per second. Yeah, that seems pretty good. Small numbers. Alright, so where are we at now? Okay, so on camera move, we send the position to others. We throttle using RSJS every 100 minutes. I send it. We also need to save the position rotation to session storage, and also store this in the ets table. We've kind of handled broadcast to all connected users. Broadcast to other user. We haven't really buffered. Broadcast to. Okay, so that can be a future to do. So buffer position rotation messages. So less chatty. Okay, so we need to add rotation, and we need to save the position rotation to the session storage, which we can easily do inside orchestrator. So in here, at the same time we push it, we can just save this to window.session-storage.set item. This will be, where was our previous set item code? Which was here. So we can probably make this a method it's a little bit more clear how to call this thing. What we did before was exactly this, set item position. It was a spawn point, which now it'll just be message payload. So if we were to refresh the page, I believe that the position should be preserved. So if I refresh this, if I move around, let's say here, then refresh the page. Oh, it did not preserve it. Okay, let me try the other browser. Set item. Okay, so here's our camera position. Refresh. Okay, yeah, I am over to the side. Because if I say session storage, yeah, look at that. It's way over to the side. And if I go way over here and refresh, I'm totally, let's see. Yeah, get item. Yeah, I'm totally out here. So what's interesting is that okay, I'm here. So if I say get position, I'm near the origin. If I refresh, yeah, is that what where am I? Latest one is that sent a camera moved. I think that's right. Attempting to process component. Okay, this angle was preserved. Refresh again. Yeah, that seems to work. Go back up. Refresh. Go over here. Refresh. Okay, so sometimes it does a kind of weird thing. Maybe it's because the rotation is not stored. So, okay, let's if we do this. So if we actually close the browser and open a new one, that should actually reset the session. Okay, so this is our angle. Giving a refresh here produces the same angle. If I move backward, refresh, that is retained, and move to the side. Okay, something happened there. Again, I move to the side. Huh. Okay, something to look into. Move over there. So I want to say we're sending console log saving position is message payload. That's our. Oh, wait a minute. This ain't the same because yeah, session storage from before it should be, I think, set item. Here, let me refresh the page. When we do this the first time and we say give us that, it has a key. It's a JSON object, but then after we move it and then we ask it what is it, oh, it still has the key. Space channel. Okay, it still has the key, so that is the same position. And so if I move to the left, I get 2310 -3, and then I refresh and I ask it again, what is that? 2310 -3, 2310 -3. So all of this is correct, but what is the theme active camera position 2310 -3? Okay, that seems all correct, so I don't understand why it pops over to the left. So if I go here, I'm saving this position 2110 -16. If I ask the active camera, yes, this seems to match up. Unless it's the rounding. I don't think it's the... Oh, wait. This is not right. Oh, okay. Maybe it's because of the interval. It didn't save it precisely. It saved it on the last millisecond. So we're just a little bit off because of the time throttling. And I'm okay with that. So if we were to refresh here, we'll get a little skip here, right? Yeah, we get a little skip here. It's fine. This is just to get close in case we need to refresh. I'm fine with this. Not a big deal. Maybe a little bit off. Okay. What's next? We need rotations. How long have we been at this? This is about 51 minutes. Okay, let's take a break here.